Okay, so my presentation is about homeostasis. Keep calm and maintain homeostasis. Homeostasis is the ability of all living systems to maintain stable internal conditions no matter what is occurring outside of the body. I think a helpful mnemonic for homeostasis is MACIE, because it reminds you to keep words in it reminds you of the key words in the definition, which are maintain, constant, internal, and environment. Homeostasis is important because our survival depends on it. In order to properly function, the cells in our body and all living organisms require specific conditions, which can sometimes be referred to as set points. So if our blood pH is too high or our blood pressure suddenly drops, this can affect our cells and actually cause them to stop working. And if the damage is extreme enough and homeostasis is irreversibly lost, then the result is death. All homeostatic mechanisms have three components. So they have a receptor, which senses the changes in the external environment and then provides that information to the internal environment. The control center regulates the set points and is considered to be the decision maker because it signals the effector organs on what they need to do to reverse the problem. And then the effectors, they respond to the changes. And these are typically muscles or glands, and they just take action. So these mechanisms are regulated by feedback loops. Negative feedback loops are the most common, and they bring internal conditions back to the set point. The correction reduces the response of the effector, so the correction doesn't go too far. So the negative feedback regulates itself also. Positive feedback loops are less common, because negative feedback loops are the most common feedback systems in our body. So positive feedback loops are the opposite, and they move conditions away from the set point. And they occur when conditions are purposely moved away from the set point. And the change is usually intensified, which increases the effector activity, which produces unstable conditions that are usually short-lived, but are needed to fix whatever problem is going on. So some negative feedback examples would be thermoregulation, blood sugar regulation, and osmoregulation. Some examples of positive feedback would be childbirth, lactation, ovulation, and blood clotting. So this is just an example of negative feedback for the temperature regulation. So the body temperature increases. The thermoreceptors transfer that information to the control center, which is the hypothalamus, which tells the effector organs, hey, you need to sweat so that we can be less hot, which will bring us back to our set point. And then if our body temperature decreases too much, the hypothalamus will tell the effector organs to start shivering or to constrict the blood vessels to conserve heat. And that will also lead back to our normal state. And then an example of positive feedback would be childbirth. So when the baby's growth takes up all the space in the uterus, the stretch receptors are activated in the uterus, which causes the brain to signal release of oxytocin, which is a hormone. And then the oxytocin causes uterine contractions, which increases and intensifies when you're going through labor to get the baby out. And then once the baby's out, they stop.